In this video, we're going to cover 7 things I wish I knew when I was first starting my PhD. Hey friends, welcome back to the channel. If you're new here, my name is Ben. I have a doctorate in engineering, and I help scientists and engineers develop skills and processes to efficiently create high-quality work so they can spend more time doing what they love. When I started my PhD, I didn't have much trouble turning to older PhD students for advice, but I often found that asking people point blank for recommendations put them on the spot, and as a result, I usually got generic recommendations like remember to take breaks and it's a marathon, not a sprint. If you're looking for real specific tips to not just survive but thrive during your PhD, settle in for these 7 things I wish I knew when I was first starting out. Start with the end and write it down. If you've already applied for or are starting your PhD, you surely had some reason for embarking on this journey. Maybe you're really excited to become the world's expert on something really niche and specific, or you know someone that inspired you to advance human knowledge on a particular disease or pathology. Perhaps you'd really like to work with a specific technology or in a specific industry like computer vision or renewable energy, and getting a PhD is how you're going to become a qualified expert in that space. Or maybe you worked in biotechnology and noticed that everyone with a position of authority in your company had a PhD, and they were leading people who were older and more experienced but getting paid less than them for the simple reason that they only had a bachelor's degree, and you resolved to not be a 35-year-old research associate working for a 30-year-old scientist-level team lead. Maybe you just want to earn your 3 stripes and wear that special hat. Whatever your reason, write it down and store it somewhere memorable and within reach, like the last page of your research journal or at the top of your Dropbox, OneDrive, or Google Drive directory. We're saving this for the gray day when you inevitably end up questioning why you're even doing this in the first place. Just about everyone ends up hitting a low point of motivation at some point, and oftentimes this happens multiple times over the course of your program. It's not a personal failure or something to dread or to be ashamed about. It's simply a natural response to working in an incredibly isolating environment for 4 or more years of your life. I know I personally felt unmotivated and looked at ways I could get out of my PhD at least 3 times before I made it to my defense. One of the best things you can do for yourself is to write a note or a letter to your future self when you're feeling excited and motivated to say, "Hey, me in the future, I know this is going to be a long journey, but this is why I'm doing this." When you first pull away from your work, the last thing you'll be in the mood for is some motivational letter when all you want to do is not think about your dissertation for a week or 3. But when you're ready to come back, this can be really helpful to reconnect with your sense of purpose and jumpstart the process of getting back into things. Rewire your priorities when taking courses. In undergrad, and if you completed a master's before your PhD, having good grades and a good GPA was paramount to get noticed by faculty and present yourself as a strong candidate for employment opportunities. As a PhD student, truly no one cares about your grades or your GPA as long as you're maintaining your department or fellowship minimums, which is usually at least a 3.0 average to remain in good standing. There are truly no bonus points for getting an A over an A- or a B+, and in fact, depending on the opinions of your primary advisor, it may even reflect negatively on you if you're overinvesting your time on getting top marks in your courses at the expense of your research or teaching responsibilities. Show up, put in the work, but you don't need to be the best in class anymore. You've already made it. Focus on applying what you're learning to your research, not on completing every last detail of every assignment. Use your program as a safe space to experiment with different careers. Your program is a safe environment to experiment with different career paths before you need to commit to any one thing. The unfortunate reality is that unless someone personally knows you, what's on your resume has the potential to pigeonhole you into a particular track. If all of your work experience is in teaching courses and designing curricula, and you want to transition into industry, a recruiter will see your resume and consciously or subconsciously write you off as an academic. And unless they're specifically looking for that kind of unique angle, you'll instantly be less attractive than someone who has the same amount of experience who worked for some company, even if it's in a different industry. It can become an uphill battle to change your career path once you've already gotten going in the outside world, which is what makes being a PhD an incredibly unique opportunity for short-term experiments in different work environments to find out what you actually like to do. TA a course, complete an internship if your advisor will permit it, collaborate with researchers in related but different niches, take a course or a few in a completely different department. For example, I participated in a technology commercialization program for a semester and found out that I actually loved the process of taking technologies developed in a research context and figuring out how to make a commercial product out of them. Had I only focused on doing research in the lab, taking courses, and publishing, I never would have figured that out and might have restricted myself to a career in academia had I not experimented. As another example, before I started my PhD, I volunteered as an educator for middle and high school science education programs and really enjoyed being in the classroom. When an opportunity to teach an intro-level undergraduate course came up, I knew I liked teaching, so I signed up to do it. However, because of COVID, I had to teach a portion of the semester completely online. That experience made me realize that I actually enjoy teaching in a digital format even better, because it meant that I could create course content, record it, and edit the videos with a flexible schedule rather than needing to perform in a specific place at a specific time. And the quality of my instruction was a lot higher because I could redo takes and cut out idle time during the lecture. Now I create online course content as part of my career, something I never would have discovered if I didn't experiment during my program. Experimenting in this way was great because people don't expect much from you when you're just a PhD student. You can sign up to teach a course for a semester, and if you hate it, or if you find that you're not very good at it, you can drop it the next semester and do something else, as opposed to becoming a full-time teaching professor and only then realizing after the fact that you actually hate coming up with bespoke course content or giving feedback to dozens of students on their assignments every month. Smooth is slow, and slow is fast. One of the worst feelings when doing research that you hope to publish is at the end of an intricate, long experiment, you realize that your data is incomplete, inconsistent, or otherwise questionable, and you don't know if the reason that you don't have results that you expected is because your hypothesized phenomenon is not real, or if your data collection was less than perfect and human error is responsible. The mantra, smooth is slow and slow is fast, could not be more true when conducting research, especially if it's not something that can be repeated quickly and effortlessly. It's much better to delay a 3-week experiment by a week to make sure you have a really clear plan of what data you're going to collect, on which days, in what ways, and why, than to start early and realize you need to do it all over again. This leads us directly to our next tip: prototype everything first. Big experiment coming up? Run the smallest version of it that you can before doing the big thing. A prototype is a small-scale model that is designed to specifically answer one or a small number of very specific questions. A prototype is not a let's try some things and see what happens. That's tinkering, which can be valuable in its own right, but it's not what we're talking about here. Let's say you're running a bunch of different conditions and need to collect a series of time points for each combination of variables in order to create a grid of responses. You have 3 variants of variable A and 3 variants of variable B for a total of 9 different combinations, and you think you're going to want to collect time point samples every hour for 12 hours to capture the time series of your effect. Do not design your perfect experiment, plan it all out, and then start the full experiment with all conditions and all time points on a Monday. Do not even split it up and start half on Monday and prep to do the other half on Tuesday. Pick one condition, whichever one that you're expecting to absolutely see some kind of effect, in other words, your positive control, and spend one day collecting all of your time points and doing all of your sample processing and analysis. This will help you learn 2 things. 1, is it even practical or reasonable to be able to collect all of these time points in a single day? For example, if you think it'll take you 5 minutes per condition, but it actually takes you 10 minutes when you do it for real because of the dozen things that you weren't accounting for when you were planning it out, you instantly learn that it's not physically possible to run 9 concurrent conditions with sample points every hour because it's going to take you 90 minutes just to process the first sample point. By the time you're collecting from condition 7, it's already time to start processing the next time point from condition 1. 2. Do you even need this many time points to capture the effect that you're looking for? Yes, higher temporal resolution is going to help you capture more detail in the effect that you're recording, and it's going to result in better models of your results and better looking figures. But do you actually need that high resolution to convincingly demonstrate your effect? If you collect your time points every hour and see that nothing happens for the first 3 hours, then your effect happens slowly over the next 6 hours, you can probably cut your sampling rate in half with no real effect on your results. If, however, nothing happens for 4 hours, and then suddenly your effect goes from 0 to 100 in 2 hours, you probably will need hourly sampling to record the effect. At this point, you actually need to reduce the number of concurrent conditions you're running in order to collect high-quality data and mitigate mistakes resulting from being rushed. If it takes 10 minutes to process each sample, you'll probably only want to run 3 conditions at a time with hourly sampling points so that you have enough time to recover from things inevitably going wrong during your 12-hour experiment, or to give yourself time for bio breaks and getting a snack. Work smart, not hard. We've all been there. At the department social event, there's always that one PhD student humble bragging that they spent 30 of the last 48 hours pulling off some crazy workflow to collect all this data, only to follow up with them a few weeks later to hear that their results were not great, and they need to perform a completely separate experiment and throw out all of that data. While working crazy hours may earn you the admiration of some first-year master's students and the odd masochistic faculty member, most wise and experienced researchers will view you as foolhardy or a downright idiot, and for good reason. It's cliché to say that a PhD is a marathon and not a sprint, but it is true. Dashing between miles 14 and 15 is a terrible idea if it means you're going to need to move at half speed for miles 16 through 20. Plan out your work, solicit feedback from other graduate students, postdocs, and faculty, and try your best to work backwards, from the impact you'd like from your paper, to the figures that you'll need to communicate that point, to the data that you'll need to construct those figures, and then try to work out the minimum amount of effort needed to get the data of sufficient quality and quantity to make those figures. It's easier said than done, but experience goes a long way when trying to figure this out. If you don't have enough experience yourself to make that judgment, ask folks in your bubble to lend their insight. It will undoubtedly save you hours, if not days, of suffering. And as a bonus, you can be the person at the department social event that can humble brag that you published your first paper in 6 months of working 30 hours a week, and have people asking, how do you make it look so easy? The rule of thirds. It is said that your personality is the average of the 5 people you spend the most time with. Who you surround yourself with during your PhD matters a whole lot, but oftentimes we don't have a whole lot of say as to who is in our research group and our cohorts. One of the best ways that you can be deliberate about your social circle is to follow the rule of thirds. You should target spending 30% of your time with people who can mentor you, 30% of your time with your peers, and 30% of your time mentoring others. The peer third is usually pretty easy. This can generally be fulfilled by lab mates or other PhDs in your cohort. This is especially easy if you're still taking classes, as you're essentially guaranteed to be physically in the same space as your peers for 5 to 15 hours per week. The mentor third is also pretty easy. Your primary advisor and any co-advisors, postdocs that you interact with regularly, and even more senior PhD candidates that are finishing up their dissertations can fulfill this role. Especially when you're first starting your PhD, the mentee third can often be the most challenging to fulfill, but is also the most important. When you become the senior PhD in your research group, junior PhDs and master's students will most likely constitute your regular mentee-like colleagues, but I highly recommend you take on an undergraduate research assistant or TA a course for undergraduates when you're first getting started. The benefits are myriad, but in a nutshell, we grow professionally and personally by learning from others, crystallizing that knowledge, and sharing that knowledge with others. This can be technical things like how to operate specific type of equipment or do a certain type of analysis, but this also includes things like professional development and sharing personal interests. In addition to the benefits to solidifying your own knowledge of the world, it is also very personally fulfilling and socially enriching to have variety in our regular social interactions, and following this rule of thirds is one of the most systematic ways you can do so. Obviously, it's not practical to set a timer and say, okay, I've spent 16 hours this week with my mentors, time to start hanging out with my mentees. But this framework provides a shorthand for being deliberate and intentional with who we spend our time with. Well, there you have it, 7 things I wish I knew when I started my PhD. Let me know down in the comments if any of these points in particular resonate with you, or if there's something important that I missed. If you like what we do here, a like on the video would be greatly appreciated, and maybe even consider subscribing. Catch you in the next one. Peace.